Hello, everyone. My name is Alberto Bellini. I'm working for SWARCO Italia. And today I want to take 15 minutes with you to talking about traffic management, its evolution, and the service and impact that we studied here in show. First of all, I want to introduce the mobility, so what we know about mobility and what we are studying here. We working with the autonomous vehicle and in general the evolution of the vehicle here, but the autonomous vehicle cannot work alone. He needs to be helped by the infrastructure, and this is the reason why you can see the infrastructure on the middle of this slide. And the combination of the autonomous vehicle and the infrastructure with the services and, of course, all the tools that are involved in these two big aspects are the creation and the construction on a smart city, so the city of tomorrow. As I said before, for the construction of the smart city, we need very good autonomous vehicles. And this is exactly where we are today. So we have a vehicle that is able to connect to other vehicles, to have interaction with vulnerable road users, and so on. But it's not controlled by control tower, so perfect management of infrastructure and vehicles. So the next step is the correct integration between vehicles and infrastructure. So the future with this autonomous vehicle and infrastructure connected could be help us, or in general, the final user to have a zero emission, zero congestion, zero accident, and so on. So the big 6 euro that you can see in the right part of the slide. Okay, now we put our focus on the V2X technology and the infrastructure. And in particular, we want to say, what is V2X? Okay, V2X stands for vehicle to everything. So the possibility to connect the vehicle with what you want in the street, in the road, and in the cloud. So the vehicle can chat with other vehicles, with pedestrians, with bikers, but also with the traffic control center, with cameras, to have and to build a very integrated service. Of course, to do that, we need different and particular tools. So we need the vehicle, of course, but sensor, the positioning system, so have a very great and punctual position of the vehicle and the other component of the road, and of course the data science and the computing power. With this technology, the vehicle can detect all the other people and vehicles in the street, and can adapt the driving of or the route of the driving for a more efficient and safer route and path. As I said before, the V2X application could be used for have a safer travel for final user. And as you can see, our first bullet is the collision avoidance systems, because you want to have more comfortable and safer journey when you are on a vehicle, on a car. With, for example, the V2X technology, you are able to detect potential hazard in the road, or, for example, pedestrians and bikers that are around the corner. So you are able to detect in advance this type of dangers, and you can take evasive action to avoid collision and to avoid accident in general. But the V2X technology is not only for a better, comfortable and safer route, but is also for traffic optimization. Why traffic optimization? Because you are, with the V2X, you are able to manage better the traffic and to reorganize vehicles, so cars and public transport and bikers and what you want in different paths and different routes to avoid congestion. Last but not least, for example, you can use the V2X also for punctual, so for particular point, like, for example, the parking assistance. With the parking assistance, you can use, for example, cameras to detect real-time free parking slot. So you can say to the drivers where parking is available and the fastest way to reach it. And this could, of course, increase the comfort of the driver and decrease the congestion due to the circulate of cars that are searching for a parking slot. Okay, now we want to talk about the traffic management and traffic management 2.0, that is the collaborative traffic management. So the management of traffic for the final users. Okay, what is traffic management? Traffic management is a process of controlling the movement of what you have in the street. So we can have private cars, buses, pedestrian, e-scooters, runner, and what you want. And you can control all these type of users with the using of strategies. So the strategies is something that you can modify during the day or every week, or what you need. For example, changing the traffic light cycle, the signs in the panel for the highway panel, for example, or change the markings on the road and so on. So you can use the traffic management to adapt the infrastructure to the traffic condition. In particular, the traffic management have three key benefits that are reduce congestions, improve safety, and increase efficiency. And we talk about these benefits later in the next slide. Why we have to talk about traffic management? We have to talk about traffic management because the high density in big cities can create congestion, especially during the peak hour. And this congestion, of course, create discomfort and create a high level of accidents. So we have streets that are less safe, and we have inefficient control and distribution of vehicles. So here we have to insert the traffic management in order to avoid congestion, increase the safety on the street, and have a better managing of the traffic. A little problem about traffic management, or in general, this approach is that the traffic management work with a community goals, with a community objectives, and that could be enter in conflict among individual objectives due to the individual objectives and target could be different with the community, because for example, the individual want to use the same street, the same path every day, because there is a lot of I don't know, trees or beautiful streets. So okay, he wants to use the street, and it's difficult to convince him to use another path to reach his destination. Okay, take a couple of minutes to have an overview about the evolution of traffic management. So where we started and where we want to arrive. The beginning, we have to talk about the traffic management 0.0. So a traditional setup with the infrastructure and the vehicle. Think about, for example, the variable message sign. So the panel with different messages on highway, or in general on the end when you enter on a city. So for example, reduce your speed due to the fog. Okay, this is a traditional aspect of the traffic management, because there is no interaction between the vehicles and the infrastructure. But of course, the user are able to know, to have, or to increase the awareness about his driving. The next step is a traffic management 1.0, where we have connected vehicles that are able to interact to the cloud, so the center, and to other vehicles. In this case, we take the example of the traffic light assistance, where a traffic light can send a message to the vehicle about is green and red cycle. So the vehicle know how many seconds remain for the green or for the red, and can adapt the speed to across the intersection safely. Also, the TLA can, for example, help you indicate also the correct speed to cross the intersection. But there are different type of connected connected vehicles for that can use the traffic management. The next step, so what we are working now in show and in the future, is to have the collaborative schemes. So this vehicle can collaborate by themselves and with the cloud and with the infrastructure and with other stakeholders to create infrastructure, a new infrastructure, to converge in this new infrastructure and have a common objectives. So it's not just the infrastructure that sends directly a message or an input to a vehicle and vice versa, but is the vehicle can create a message or create an input, send that input to another vehicle, and that vehicle can adapt his speed or his behavior using also these messages sent by another vehicle, and of course, by other actors. In this slide, you can see exactly what I'm saying before. So we have all the actors, or some example of actors that are involved in the traffic management 2.0, so the collaborative traffic management. So we have some stakeholders that provide a traffic management plan. We have the service provider, we have the road operators, and we have the end user. All of them communicate to create a visual gun along road, so to create this traffic management 2.0. So now we try to shift from an integration between vehicles and infrastructure to an interaction among all the partners. This TM 2.0 are able to have a more accurate and predictable network forecast due to the multiple of data that is able to analyze. Also, the traffic management 2.0 is a good balance between the individual needs and the community needs, because you can also have the input from the end user. So if you want to use a particular route, a particular street, the TM 2.0 take also that in consideration. This traffic management 2.0 is also important because it's very useful if we are talking about the autonomous driving, because of course the autonomous driving needs data from all the environment around it. So he can use different type of data, different type of needs, and use it for a very good experience on the street. What about the key challenges that we have? The key challenges is about the integration of the traffic management in not only the microscopic but also the microscopic level, because you can have a very particular level, but you also need a general one. So not focus also on the pilot, but on the whole cities. It's complementary to the ODD concept also. So for this aspect, it's very important. And the key challenge is probably one of the more important challenges is the connection and inputs to standards, because if we are talking about autonomous vehicle, we have different standards in different countries, and traffic management have to be compliant with all of these standards. Here we can see the traffic management services that we studied and investigate during the show project. And in particular, I tried to divide them in the three key benefits that I showed before. So the safety, the congestion, and the efficiency. We are different type, of course, of services that include different stakeholders and different type of vehicles, for example. Someone is for private, and someone is for the public, and also for example, the pedestrian. In particular, I want to show one example for each of these key benefits. One of these services could be the proactive maintenance, and it followed the key benefits of the safety, increased safety. The objective of proactive maintenance service is to allow an optimized sharing of road and traffic information to improve the management of pavement roads and the road environment. As you can see in the image on the right, we have, for example, a vehicle that is running on the street and detect some particular pavement surface, so some particular substances on the pavement surface, for example, ice or slippery on the surface. And after detecting it, can send a message through DETEX or SECAM messages to the traffic management center. And the traffic management center can share this information with the road maintenance system, which will decide if the roads need maintenance or not. Road sensor, of course, can help to have a more precise notion about this slippery road or ice on the road. Of course, you can intervene on this problem, so this ice, for example, on the road, and rush over this problem. Another, for example, about the key benefits of the congestion is the platooning support. We know that the platooning and the using of platooning is a very efficient and important service for the traffic and to reduce congestion, due to avoid loss in time when you are, for example, an intersection or during the green and red cycle, or on the highway, for example. The platooning is very powerful service. The traffic management could help the platooning implementing strategies, for example, with the autonomous vehicle or with connected vehicles itself. For example, the traffic management can inform connected and automated vehicles about new road or the sustainability of a road segment or lanes that is specific indicated for platooning, or can give, for example, a recommendation or particular parameters, for example, the correct speed for a class of vehicles, and the presence of other platooning train in a specific road, so the vehicle can go and go over this platooning or this other platoon. So a couple of information that the traffic management could provide is the maximum number of vehicles in a platoon. So know how many vehicles are involved in this platoon and the size of this platoon. But also the platoon section, so where platooning is possible to create, and the infrastructure, and if the infrastructure are able to support the platooning or not. Last one, and for the last key benefits, is the growing priority, so increase the efficiency of something. In this case, we can increase the efficiency of the traffic light. In this particular case, we can have a prioritization of a public transport or a vehicle, an emergency vehicle, to traverse a signalized intersection as fast as possible. In that case, for example, we have a vehicle that have to cross an intersection and send the traffic management center a specific message that asks for a prioritization. And after that, the traffic management recalibrate, so readapt the cycle, the green and red cycle of the traffic light to try to guarantee the green on the approaching vehicle. Okay, in this slide, we can analyze a bit deeper the ground priority service that is the one that we implemented in the pilot, in the Turing piloting show. Okay, starting from the left, we can see the shuttle, so the autonomous shuttle that asking for a prioritization, so inform the cloud or in general the RSU that is approaching to the specific intersection with a SICAM message. SICAM message can inform you about the position of the vehicle. The RSU or a cloud system can elaborate this position and send to the traffic control center a message for a request. So the SREM, that is a request messages, senior request messages. Then the traffic control center can elaborate all this information and also using the traffic control, the traffic light control, so the status of the green and the red cycle can answer to the vehicle and can say if the request is guaranteed or not. In a positive way, the traffic control center respond with an SSM messages where you can see, okay, you are the prioritization, or no, you cannot have the prioritization. If the prioritization is confirmed, and the cycle of the traffic light is modified to permit to the autonomous shuttle to never stop and cross the intersection safely. Of course, this is the message that you, the chain of the messages that is needed to this service, but of course you also need the SPATM and the MAPM messages that are able to identify the traffic light, so they identify the controller, and the MAPM that is needed to identify exactly the intersection, so the number of lanes, and the possibility of maneuver, and so on. Okay, I ended my presentation, my training, and this is the traffic management and the possibilities to traffic management also for future steps. Thank you everyone, and bye-bye.